Welcome to LinMot Tutorials. In this tutorial, we will size a DMO3 for the Z-axis of an XZ pick-in-place. We will begin by going to the Load tab in Global Settings and adding the tooling mass. In this case, the tooling mass is 2,000 grams. We will then select the vertical down as our motor's orientation. Next, to select the proper DM guide, we will go to the Motor tab and click on the Motor box. Under Category, select Linear Motor with Guide. Under Group, select DMO3. The family for the sizing will be the DMO3 37x120 motor. We can leave the type at the 95mm stroke with the 40 Newton MagSpring for now, as it fits our application. Cables are selected according to the motor and drive type. We will select a K05 4-meter cable. We will uncheck Add Typical Supply Capacitance because we will be using our standard 120 volt power supply, which has a 390 microfarad external capacitance. Now we will create our motion profile. The first segment will be a sine move of 70 millimeters in 300 milliseconds. In segment 2, the motor will retract to its original position. This will be a sine move of negative 70 millimeters in 300 milliseconds. In the local load settings, we will add 500 grams of mass for the part that is being picked. Segment 3 will have a local mass of 500 grams for the part that is being picked. This segment will be a 500 millisecond standstill. In segment 4, we will place the part. This will be the same as segment 1, except it will also have a local mass of 500 grams for the part being placed. Note that we have an end position error. This will go away when we return the motor to its original position in the next segment. In segment 5, the part has been placed, so the local load mass can be removed. Segment 5 will otherwise be the same as segment 2. Segment 6 will be another 500 millisecond standstill. Now we will size a MagSpring for this application. First, we must go to the Load tab in Global Settings. Here, we can see the system friction is 7 newtons. This will be the force we must overcome for the motor to move upwards using a MagSpring. To check the upward force the motor is experiencing when idle, check the segment results on the left side of the window for the 2 standstill segments. Segment 3 has a negative peak force, meaning it will drop without power. Segment 6 has a positive peak force, but it does not overcome the system friction, so it won't rise without power. To try a MagSpring with a higher force, go back to the motor you selected. Under Type, click on the motor of the same type with the MagSpring of a higher force. Let's try the 50 Newton MagSpring. It looks like both segments' peak forces are positive and above the system friction of 7 newtons. Note that the standstill at segment 3 has a lower upward force than the standstill at segment 6. This is because segment 3 has the 500 gram part, while segment 6 has only the motor weight. Note the bottom left corner also shows no errors or warnings. This concludes our sizing and the tutorial. Thank you.